Good morning. Welcome to the Humanist Community Sunday Forum to those joining us on Zoom and those here in person at the Mountain View Community Center. My name is Ray Sunby. I'm the president of the Humanist Community. The Humanist Community is a chapter of the American Humanist Association. Humanism is a reality-based philosophy of life that affirms our ability and responsibility to acquire knowledge that aspires and apply that knowledge for the greater good. We value fairness, reason, honesty, respect for others, using science and reason to acquire and apply knowledge. If these words describe your thinking, we ask you to become a member of the Humanist community by going to our website at www.humanists.org. You can find out about upcoming forums and other activities at the website. Please help us to continue to present these forums free to the general public by contributing to the Humanist community at our website, www.humanists.org.
Today, our speaker is David Friedman. He's going to talk about the consequences of climate change. Our speaker, David Friedman, is the son of economists Milton and Rose Friedman. He graduated magna cum laude with a degree in chemistry and physics from Harvard University, and has a theoretical physics degree from the University of Chicago. He's best known for his writings on economics. He taught law at the University of Santa Clara and is currently a Professor Emeritus. Please welcome David Friedman.
Thank you. I like to describe myself as an academic economist with a doctorate in physics who spent the last few decades in law schools. What? Oh, sorry. You want me to hold this thing?
Yeah, hold it. Okay, good. Yeah, hold it close to your mouth.
Right. My interest in climate really comes out of my interest more than 50 years ago in a parallel issue. As some of you may remember, back in the 1960s, the perils of population growth occupied essentially the same role that the perils of climate change occupy now. It was the looming catastrophe, which was going to do horrible things to the world if we didn't do something drastic to stop it. I got interested, and I ended up writing a piece for the Population Council, trying to calculate or estimate the effect on other people of having one more child. Everybody took it for granted that it was negative, and I was dubious. And I concluded that there were both costs and benefits to the outside world to having another child, and that they were sufficiently indefinite that I could not tell whether the net effect was positive or negative. I think what's happened since then is consistent with that. The horrible predictions turned out to be wrong, and at least some of what it resulted in did a great deal of damage, in particular the one child policy in China and quite a lot of sterilization in India. So when climate became an issue, the same question occurred to me. And I'll give away the answer. I concluded that, again, there are both costs and benefits to climate change, and they are sufficiently uncertain that we cannot tell whether the net effect is good or bad. If you think about the question, there are really two ways of approaching it. One of them is to ask a priori, do we have a reason to expect that the kind of climate change we're expecting, which is basically warming and some related effects, will have good or bad effects? The current climate of the Earth was not designed for us, nor were we designed for it. Our species evolved over a period over which climate has changed quite a lot, and we currently live in places with a wide range of climates. The variation at present over space is much larger than the projected variation over time. As I like to put it, if the IPCC is right, by the end of the century, Minnesota will be about as warm as Iowa is now. As far as I can tell, there's only one reason to believe in advance that climate change is bad, and that applies to both warming and cooling. And that is that lots of decisions people make are optimized against the present environment. So if you're a farmer, you're growing those crops that grow best in the present environment. If you're building a house next to the sea, you assume the sea will stand still and therefore you can build it safely close to it. There are a whole bunch of what economists think of as sunk costs, where we've done something and the benefit of that something depends on the environment that it's optimized against. So that's a reason why change can be expected to have some costs. On the other hand, the change that we're projecting is extremely slow. If you actually look at what's happened with climate change, roughly speaking, so far, global temperature has been going up by about a degree centigrade per century. The IPCC thinks it's going to be maybe 2 degrees per century for the next century. That's a pretty small change. So any farmer is going to have changed his crop variety several times before climate change matters for other reasons. Houses, I happen to live in a house that's more than 100 years old, which is very unusual in this area, but mostly houses do not stay the same for centuries, at least in America. Some other places they're more likely to. So I think as far as effects on humans are concerned, there's no a priori reason to expect change to be bad or good. On the other hand, there are other species involved, some of which are important to us, some of which evolve slowly, and some of which move slowly and therefore can't easily shift their range. So I think it's at least possible that some of the effects of climate change on other species which are optimized against their present environment might be serious and negative. And the clearest example of that is decreasing pH of the ocean, where we just don't know whether that will have significant effects on ocean life, and ocean life matters to us in lots of obvious ways. The other way of looking at the question is to try to actually look at the various costs and benefits and add them up, as it were, try to see how large they are. And I've tried to do that. Mostly, since I'm not a climatologist, I've accepted the IPCC projections and tried as an economist to figure out what the implications are. What are the costs that can definitely be expected from climate change? One of them is sea level rise. It is reasonably certain it's happening already. On the other hand, it's pretty slow if you actually look at it. The current IPCC projection, the high end is maybe a meter of sea level rise by the end of this century. That's what, half the distance between high tide and low tide. So it will certainly have some effect in some places that are very low lying, but I don't think it's likely to be a very large effect. Heat waves. It's reasonably clear that if you make the world hotter, that the result will be that some people will die from periods of unusual heat. Then there are some costs which I list as possible costs because we can't really be very sure of them. One of them is the reduced pH of the oceans. I don't think we know whether that will impose costs, but it could. One of them is the effects of climate change on agriculture. I think people tend to overestimate that because they're not allowing for the fact that farmers adapt to the environment over time, and they're going to have time to do it, that you can change where you grow which crops and so forth. But that could be negative. Certainly some people think it is. Projections suggest that we're going to have more rain, but the rain is likely to be more concentrated, and that could result in problems of flooding. On the other hand, if you actually read the IPCC report instead of the summary for policymakers, you discover that some projections have climate change greening the Sahara and the Sahel, so that in fact there are likely to be effects in both directions on plant growth. Next, what about the positive benefits? The most certain benefit, indeed the most certain effect of climate change, is CO2 fertilization. CO2 is an input to photosynthesis. There is an extensive literature experimenting on the effect of raising CO2 on crop yield. There are basically two forms of photosynthesis that exist, called C3 and C4. Most crops are C3. Maize in particular is C4. It's the big C4 crop. C4 is a more efficient form of photosynthesis and does not benefit in yield, at least not very much, from increased CO2. see three crops, roughly speaking, if you double the CO2 concentration, which is roughly what the IPCC expects by the end of this century, you increase yields by about 20%. So we're talking about a huge increase in total crop yields. And that increase is a result of the first step in the process. The increase, it doesn't depend on your modeling of how CO2 affects temperature. It doesn't depend on your modeling of how CO2 affects rainfall. It just depends on increased CO2, which is the starting point of the causal sequence. So in that sense, I would argue that the increased crop yield from CO2 fertilization is the most certain of the effects. Next important one. At the same time that greenhouse gas warming increases maximum temperatures, it also increases minimum temperatures. So it means that you have more heat waves, but less, and more extreme heat waves, but less cold waves. Furthermore, the effect on minimum temperature is larger than the effect on maximum temperature. For reasons which I can go into if people are curious, greenhouse gas warming is larger in cold times and places than it is in hot times and places. So the pattern of greenhouse gas warming is in fact biased in our favor, because as a general rule, warming is a good thing when you're cold and a bad thing when you're hot. Furthermore, globally, deaths from cold are much, much larger than deaths from heat, something like 10 times as large. For the US, I know of an article by some CDC people, which concluded that for the US, it was about twice as many people died of cold than of heat. So while you could expect the increase in high temperatures to kill people, you should also expect the decrease in low temperatures to reduce deaths. And I don't think I know enough, and I'm not sure anybody really knows enough to know which effect is larger. There's no good reason to expect the bad effect to be larger. Finally, something else that mostly gets ignored. If you try superimposing temperature maps of the globe with population density maps of the globe, with both of which you can find online, you observe that human land use is restricted by cold, but not by heat. That is to say that when it gets in areas that are very cold, i.e. polar regions, essentially nobody lives, almost nobody lives, very low population densities. On the other hand, some of the hottest areas of the world, defined by either average or maximum temperature, you can find maps for both, are densely populated. The Philippines, for example, is a very hot region. What happens as you warm is the temperature contours move towards the poles. So that means that areas, South Pole, it doesn't much matter because the only land, Antarctica is not going to warm enough to be settled, and Argentina is already settled. But in the northern hemisphere, that means that very large areas of land in northern North America, Scandinavia, and the biggest gainer is Russia, are going to go from unlivably cold to barely livable. And that means that areas south of that are going to go from barely livable to tolerably livable, and areas south of that, and so forth. So you're talking about a very large increase in the amount of the earth that is actually habitable by human beings. Habitable is a practical matter, and that human beings can grow crops on. And I've got a back of the envelope calculation. At the end of this, I'm going to point you at some of the stuff I've got webbed, because there's no reason you should believe me without looking at the calculations. But my rough estimate is that a 3-degree warmth, a 3-degree increase in global temperatures will give us an increase in land roughly equal to the land area of the United States. It's not a trivial effect, and that's roughly what you expect by the end of this century. So that gives you 3 big positive effects. to balance what are the negative effects where, as I say, sea level rise is a real negative effect, but if you work it out, the amount of land area is tiny compared to the increase due to the shift of the temperature contours. Then the question is, why does everybody think the opposite? Why is it that what I'm describing is heretical rather than orthodox? And I think if you look at it, and I've been looking at it for quite a long time, part of the answer is a very biased presentation. And let me give you three different examples that I think I've got three that I've come across. One of them is the IPCC summary for policymakers, which is all that the newspaper reporters who write stories about the IPCC reports are likely to read. One of its assertions, true assertion, I should say, is that the projection of the effect of climate change is that it will increase the proportion of tropical cyclones, that's hurricanes and typhoons, I guess is the other term, depends which ocean they're in, which you call them, will increase the proportion of the high end, the 4 or 5, to the low end. All right, that sounds as though it's getting worse. You then go and you look at the actual body of the report, and what the projection is that the number of high-end tropical cyclones will stay about the same, and the number of low-end ones will go down. Well, describing that as the proportion of high-end ones going up is a deliberately misleading presentation of what is in fact a true fact. Now, they also say what's also true, that the high ends are expected to get a little bit fiercer, a little bit more powerful. That's a true negative effect projected. But then the decrease in category 1, 2, and 3 hurricanes and typhoons is a benefit, which they are managing to hide. Again, the summary for policymakers has this nice map of the world divided up into a bunch of regions showing where drought is increasing. And there are lots of regions where drought is increasing and only, I think, 1 or 2 where it's decreasing. The body of the report mentions that the Earth on net is greening, that more area is covered by plants, not less. How are these two facts consistent? I think I know the answer, though I'm not certain. In addition to the effect of CO2 fertilization on crop yield, it has another effect on both C3 and C4 plants, which is to reduce the need for water. That if you have a higher density of CO2, the plant doesn't have to pass as much air through its leaves in order to collect the carbon that it needs for growing. And since it's passing the air through the leaves where it loses water by evaporation, the result is that if you have a plant which is water stressed, where it does not have adequate irrigation, it will do better when there's more CO2. If you read the notes to the summary for policymakers map, you discover that they are defining drought not by the condition of the plants, but by the amount of moisture in the soil. Well, if it is true that you get less moisture in the soil, but it's also true that increased CO2 means plants need less moisture, that would explain why drought by one definition is increasing and yet the total planet is greening. But you don't often see people reporting the fact that the planet is greening. Let me give you a second example, and this is one I spent quite a lot of time on, and if you like, you can go to my webpage and find a very detailed article on it. There is a fairly recent article in Nature which tried to estimate the cost of carbon, how much worse off we are for each ton of carbon dioxide that goes into the air. They came out with a figure about 3.5 times as large as the previous figure that had been calculated under the Obama administration. Under the Trump, I think it went to 0 or something close to that. They're doing the calculation from now to 2300. That should be enough all by itself to tell you that this is trash. We cannot predict the future well enough to know what will happen for 300 years. Putting that aside, let me go through a couple of the details. Roughly half of the total cost they have is the mortality cost from increased temperature. So they have some estimates from the recent past of how much mortality goes up when temperature goes up. They then use those estimates for the next 300 years. One of the things that affects mortality from temperature or anything else is medicine. Their calculations are implicitly assuming that there will be no medical progress for the next 300 years. Second thing that affects it is income. Poor people have to go out in bad weather and rich people don't. And rich people are much better able to insulate their homes and pay for air conditioning. On that article, on the Renard article's model, per capita income is increasing about threefold by the end of this century, a little more than tenfold by the end of the period they're looking at. They entirely ignore that in their calculation of mortality from temperature. So that's a case in which they have ignored two very large effects, one of which can't be predicted. If you did a careful enough job, you could measure the effects of income, at least by looking at different countries, but they don't try to. And there isn't any good way of predicting the effect of medicine. I have in my article a couple of things where I look at how much mortality has decreased from medical progress in the recent past. And if those changes continue, it implies that essentially very nearly all of that half of their cost is zero. That is to say that, 50 years from now, it'll be much, much lower than it is now. But we don't know. You can't predict it. As I say, my most fundamental objection to that article is the whole idea that they can make any plausible guess at what the world is likely to be by 2300. So I should say, one of the related points is that at the end of that article, they have devoted a couple of paragraphs to the reasons why the real cost of carbon might be higher than the figure they calculate. They say nothing at all about reasons why it might be lower, despite the fact that, as I've just pointed out, there are two large effects, each of which could drop, say, by 25 to 50% what their estimate is, which they say nothing at all about. So that's one example. And the fact that Nature published that article, the fact that the EPA is now looking at that article, maybe they finished, but they asked for comments on it, it seems to me says something about just how biased the discussion of these issues is. That if you have a complicated problem and you're trying to get an answer, you make a whole bunch of judgment calls. And if you already know what the answer is, all the judgment calls go one way. Right? Let me go on to my third example. And my third example is an elementary textbook in climate science, Introduction to Modern Climate Change by Andrew Dessler, who is somebody you also often see online talking about climate change. And I was curious about it, so I read it. And he has a chapter on the consequences of climate change. It does not list a single positive consequence. The book never mentions CO2 fertilization. The book, of course, never mentions increased land availability. It does, in a different chapter, mention the fact that you have fewer people dying from cold, but he asserts with no basis, that is, at least he doesn't cite any basis, that many more people die from heat than from cold in the US. A statement which, as best I can tell, is precisely the opposite of what's true. As I say, I cite an article done by some of the CDC people, which concluded by reading the documents for deaths, what theirs are called, that roughly twice as many people in the US die from cold as from heat. And as a much simpler thing to look at, if you just look at a graph of mortality over the year, you notice that it is relatively high in winter and relatively low in summer, which could have other explanations, but it certainly suggests at least the same pattern. So that was one of the things that bothered me. A second thing was that he's got this very wonderful claim about the effect of sea level rise on Florida. And he basically says that if you take the midpoint of the projected sea level rise by the end of the century, about 9% of the land area of Florida will have flooded, and that land area will have about 10% of the population of Florida. And I didn't believe it. It struck me from what I had seen about sea level rise, it seemed high. So I checked his sources. And it turned out that the source he cites is not a journal article. It's not a peer-reviewed article. It's a piece commissioned by an environmental group. Furthermore, if you look at it, you discover that the sea level rise he's citing works out to be 60 centimeters. He says the midpoint, and he gives you both endpoints. The sea level rise, however, in that source is 68.6 centimeters. And then you read that source and you discover they're going off their source, which is actually a journal article. And that journal article is calculating the results for 80 centimeters, right? So he's used things calculated for 80 centimeters and claimed that they are true for 60 centimeters. But it gets worse, because I was also struck by the claim that 9% of the land had 10% of the population. So I used the source's source, which has a map, which shows what areas are going to be flooded. And I superimposed that map on a population density map of Florida. And let me do a share screen at this point. That is it. You will observe the black lines are showing the flooded areas. You will observe that the bulk of it is basically the Florida Everglades, where almost nobody lives. There is one tiny bit up at the top right where, no, I guess top middle more nearly, where a little bit is flooded that has people living in it. But overwhelmingly, the flooding projected by the source of his source is in places with very low population density. There is no way that can produce a percentage, that can flood a percentage of the population that is larger than the percentage of land area, which is the claim he made. I should say I corresponded with the author of it. He doesn't have any explanation for any of this. He just says, look at it. I should also say that this is a textbook that's in its 3rd edition. So that means that either no professor who looked at it ever noticed that it was saying things that weren't true, ever bothered to check its facts, or they noticed they weren't true and didn't tell the author, or they told the author and he ignored it. And I figure I'll wait till the 4th edition to find out whether he is a fool or a rogue. That is, whether he is deliberately doing this or whether he just isn't bright enough to realize what he's doing. All right, so those are my 3 examples, and I could give you many more, of course. I've been doing this for like 15 years or so, mostly on my blog. 3 examples of heavily biased reports in respectable places. All right, I'm not talking about fringe groups. This is a elementary textbook that's used enough to be in its 3rd edition. This is a published journal article in Nature, which is a top journal, and an article that the EPA claims to be looking at for deciding how their regulation should go, and the summary for policymakers of the IPCC report. Those are the 3 examples I could offer up. Others. So general points. First, the one I already made, that if you're looking at a complicated question, and the attempt to calculate the cost of carbon for 3 centuries is a very complicated question indeed, probably an unanswerable one. But if you know what the answer should be, you make all your judgment calls the same direction, and sure enough, you get the answer that you expected. Second point is that the popular discussion is much worse than the scholarly discussion. That the popular discussion treats climate change as in 20 years or in 50 years we'll all be dead, or at least the world will be terrible, and all sorts of things of that sort. William Nordhaus got a Nobel Prize for his attempts to estimate the costs of climate change. He's an economist. He has a piece of some years back which was responding to a Wall Street Journal op-ed. And the Wall Street Journal op-ed was arguing essentially climate change is not the sort of urgent issue that requires drastic action now. And he was attacking that. And in attacking it, he gave his estimate of what would be the total cost of waiting 50 years to do anything. If you compared how well off we would be if we waited 50 years to do anything with how well off we would be if we took the optimal policies for dealing with climate starting tomorrow. This is a few years ago that he wrote this. And his answer is $4.1 trillion would be the total cost, to which he adds wars have been started over less. And then you think a little bit and you say, wait a minute, this is $4.1 trillion spread over the entire globe, and at least roughly a century. He's a little unclear in that. And I think if you actually go to his book, he's summing costs over more than the next century. But if you assume it's the next century. So that works out to be a decrease in total global GNP of about 1/20th of 1%. Not my other quote from Nordhaus, which is not about changing, but about the total costs of climate change. And I quote from his book is, "The best guess in this book is the economic damages from climate change with no interventions will be on the order of 2.5% of world output per year by the end of the 21st century." So if he's right, by the end of the century, per capita income will have gone up by 2.5% less than the roughly tripling that it's projected to do. If he's right, that's a cost. That's a reason for doing things. But the idea that this is a looming catastrophe just does not fit those numbers. One final point, I think I'm almost done, is that a lot of the talk implies that the present temperature of Earth is unusually warm and getting warmer. And that is not actually true. It is true, whoops, sorry. There we go. This is a graph of the global temperature over the last 500 million years. And you will notice that although it has, wait a minute, it's not showing, for some reason it isn't showing the end of it. Very good. You will notice that although it is indeed going up at this point, it is going up from quite a low level in terms of geological time. You might also notice that we are in an ice age. All right. The geologist's definition of an ice age is the time when there is ice on one or both poles. And everybody talks as though the melting of the ice caps would be a sort of an unparalleled catastrophe. Through most of the history of the Earth, we have not been an ice age. That's the coloring of that line, basically. That's the world without polar caps. And with polar caps, we're about halfway back at this point. That's not all recent warming, to the dividing line. But if you look at that, you can see that as little as 100 million years ago, temperature was, more than 10 degrees, maybe 12 degrees centigrade higher than it is now. So we are not talking about changes that threaten life on Earth. We are talking on changes that may turn out to be inconvenient for human beings. They may not be, we're not sure. I'm not sure, at least everybody else is sure. So I guess I can, I guess the other thing that I wanted to show, oops, there we are, is where you can find more detailed information, because I'm really giving you conclusions. You should not trust conclusions. That is to say, you have no particular reason that I'm an unbiased source of reason to think that I'm an unbiased source of information, and I'm not. As it happens, climate change is used as an argument for policies that I'm inclined to be against. I therefore have a reason to try to look for arguments to show that the orthodoxy is wrong. So you should consider those as interesting arguments. But then if you would like to see the support for it, the first link up there is my webpage, which has links to most of my nonfiction books, to most of my articles. The one down At the bottom is my blog. I'm not doing anything on my blog nowadays, but it's got a lot of stuff on it. And the reason I'm not doing things on the blog nowadays is that I have a Substack, which I've been putting posts on every 3 days. However, what I still have on the blog as the current post is a list of the Substack posts. So with links. So if you want to look at my Substack posts, which are nothing like all about climate, but maybe a quarter of them or a fifth of them or a sixth of them are about climate. So you can find detailed information there. This one, which you're probably not going to be able to get unless you photograph the screen in some way, is a link to a collection of chapter drafts, which I intend to eventually turn into a book or two, or maybe 2 books, which are on my webpage. And if you go to that, all right, I'm not sure what I can do here, but let me try it. Can I? See if I can actually go to. There we are. That's chapters which started out as ideas. Basically, some years back, I concluded that I had no new ideas that were worth writing a book about. But I had 15 years or so of old ideas on my blog. So I went through the blog, sorted stuff, and created chapters. Some of them were entirely new, but mostly were based on ideas in the blog. And at the bottom of this, as you can see, I cover a whole bunch of things. I cover libertarianism, which is my political position, religion, education, marriage, reproduction, and genetics, economics, but down at the bottom is climate. And you will find, for example, my analysis of the Dessler book in detail. You will find my calculation of land gained and lost through temperature shifting, and so forth and so on. Also my critique of the Renner et al. Article. So if you are sufficiently curious and you want to see the basis for the claims I'm making, you can find a whole bunch of stuff there. I should say, by the way, with regard to my land gained and lost, I cite 3 different articles by other people who tried to do much fancier versions of that. And they are much more sophisticated versions, but I think I'm inclined to trust them less because they're all complicated. And unless you are yourself an expert in the field and willing to spend, weeks or maybe a couple of months going over the article, you can't tell if it's true. So what I'm doing is what's sometimes referred to as a Fermi estimate or a back of the envelope calculation, in which I do a very simplified model, but one where you can actually check it because all of my sources of information is stuff available on the web. Anyway, that's sort of a general comment of not really about climate, but the whole problem of figuring out what is true in the present world, which is not a trivial problem, that there are a whole lot of things that people believe that turn out not to be true. Some of which have lethal effects. For example, the belief that margarine was safer than butter almost certainly killed several million people. That was a belief that was widespread, as many of you will remember at one time. It turned out that, in fact, saturated fats had, if anything, a small effect on mortality. Trans fats, which is what the margarine we were switching to, have a large effect on mortality, and a whole lot of people were making themselves more likely to die as a result of believing what was at that point the orthodoxy. Anyway, that's nothing to do with climate, but just one of the things I find interesting is this whole problem of sifting the available information and trying to figure out what's true, and much of the time you can't. Thank you.
Thank you, David. So I don't, Michael, I see your hand up.
Thank you for your work. I think this kind of research it's really important. And I have 2 questions to you. Do you want to answer one by one, or
sure? If you have 2 questions, I'll be glad to listen to both of them. My machine seems to have lost, for some reason, the Zoom, and I'm not going to try to get it back again. So what's your question?
So my first question is that as a scientist, of course, you know that in science, the independent verification is a key. So I'm wondering if anyone else is doing the similar research to yours that could independently verify some of your conclusions and using the same methodology or different methodology. So I'm wondering how much of this can be considered as sort of peer review.
Well, there are a number of people who are sometimes referred to as lukewarmers, of whom Bjorn Lomborg is probably the best known one, who have, that they're not looking at my work, but they're doing similar estimates and reaching similar conclusions. But I don't know, it's an interesting question. I don't know of anybody else who is, I don't know of anybody who is looking at my stuff, anybody serious, any professionals, as it were, who are looking at my stuff and can tell me why I'm wrong, which I might be. I did, as I say, correspond with Dessler at some length by email, and I went through what was wrong with his book. He did not, in fact, have any rebuttals, but that doesn't prove I'm right. It just proves that he doesn't know why I'm wrong. You had a second question?
And sorry, what is his name again?
The Dessler, Andrew Dessler, I think. That's the elementary textbook that I mentioned, and he is somebody who is very often comments on climate stuff online. You will see him if you watch that kind of. Just a minute. Let me get it. I am afraid that I do not.
Oh, okay, I see it in the chat. Sorry.
All right.
Don't worry.
Andrew Dessler, Dessler.
And my second question is that my understanding is that the main concern with climate change is not this gradual increase in average temperature, and this is probably the things that happened in the past, and people could adjust to this. It's not by itself the main problem. The main problems are two. One is the increased probabilities of extreme weather events, which are probably hard to estimate and hard to predict.
Of extreme what?
Extreme weather events, like hurricanes.
I understand.
Droughts.
What does that statement mean? How do you add up? We've got a whole bunch of different things that are being changed. Some of them, we expect more extreme heat and less extreme cold. How do you decide whether that's a net increase in extreme events? We expect to have somewhat more extreme category 4 and 5 hurricanes and fewer categories 1, 2, and 3. How do you decide whether that's a net increase in extreme events?
Excuse me, David, could you speak into the microphone?
I'm sorry. My point is, I'm reacting to the fact that you're giving a very common factoid, and before you decide whether it's true, you want to decide whether it means anything. And as far as I can tell, the factoid is normally stated, unless you claim that all extreme events are increasing, which we know is not true, the factoid doesn't actually mean anything unless you have a very detailed description of what categories is extreme and how we add up different kinds of extremes.
I am not saying anything about the impact of this event, but I am wondering about how much does it affect this your conclusions, because this is different from just regular increase.
Yeah, but the particular extreme events that are supposed to have bad effects are extreme heat, extreme hurricanes, and maybe extreme rainfall. That's the standard list. And as I have said, extreme heat, we can expect more extreme heat, but we can expect extreme cold to decrease, to get less cold by more than we can expect extreme heat to get hotter. And if you look at the IPCC reports, if you look at the maps, for example, you observe that temperature increase is much higher in cold areas than in warm areas, projected temperature increase. And they also have tables where you can look at the numbers. So that is a negative effect. It's a negative effect, which I listed at the beginning of my talk, but it is balanced by a positive effect, and we don't know for sure which is larger. Similarly, the fact that you will have somewhat more powerful hurricanes is at least the projection, and that will do some damage. So far, if you look at what's happened, it looks, and this is what the IPCC says, as though increases in hurricane damage are almost entirely due to there being more stuff in coastal areas to be destroyed, not to hurricanes getting worse. But it is projected that they will get somewhat stronger. At the same time, it is projected that there will be fewer of the low-end hurricanes and typhoons. So, well, I guess the rainfall I don't know about, but so anyway, so I don't think that the general statement that extreme events are getting more common means anything, at least unless you have a much more detailed account of it, even though it's a very popular factoid. And the particular ones that I know about, I have included in my discussion, and they are among the things that are costs, but those costs have to be balanced against benefits, which tend not to be gotten.
We have some other hands up.
Yes, yes.
No, actually, we go in order. So
I'm sorry.
Yeah.
Right.
But I have not finished yet asking my second question.
I'm sorry.
So, and the other maybe even bigger concern is that at some point there will be some new positive feedback loops that will change the whole atmospheric and ocean circulation, and it will be a kind of a phase transition in our global climate system that could bring some qualitatively new effects. No? And it could be a point of no return that some models are predicting. And this probably would be a different story, right?
This might be believable if current temperatures were in fact high in terms of the geological record, but they aren't. It's hard to believe that we are unstable at the current temperature when we have been through a temperature 13 degrees centigrade higher about 100 million years ago, and the world, nothing collapsed. There wasn't a catastrophic anything. Mammals did pretty well. Some organisms in the ocean seem to have vanished, and others have increased. There was a good deal of speciation. So again, I don't see any reason to expect catastrophic changes, although they make nice news stories, and the newspapers have an incentive to tell good stories.
Okay, we're spending a lot of time. If you have more than one question, raise your hand again later. We'll get back to you.
All right.
Matthew.
Second. So if I only got one question, my first question is basically, have you received any money from the oil industry or any groups related to them? Or do you get any support
An
from?
interesting question. I own a variety of stocks. Almost about 3/4 of my portfolio is the combination of Apple and Microsoft, both of which I prudently bought very early. I think that among the stocks that either my wife brought in or that I inherited from my parents, I think there is at least one oil company. I have not received any money from oil companies in any form other than dividends on publicly traded stocks.
Or any monies from groups related to oil companies, third parties that may be supported by them, that to your knowledge?
Not to my knowledge. I have sometimes given talks where presumably the talk was being funded by some group, and I can't guarantee that whatever group funded it did not get donations from oil companies, but I'm not aware of any connections to oil companies.
Okay.
Santa.
You may already have covered this, but it was my understanding that as the water because of the ice and all that got colder, and as the tropical forests are going away, that we would have problems with the Gulf Stream. What do you think about that?
I don't know.
Oh,
That is basically, as I think I said earlier, I'm not a climatologist. I'm basically reading IPCC reports and trying to see what I can get out of them. And I have not, but it isn't impossible. But of course, let me give the other half of that. And that is, we are currently in an interglacial. That is, people use the term ice age very loosely. But strictly speaking, an ice age is a period with ice on the poles. We've been in one for about 3 million years. And the ice age has alternating glaciations and interglacials. We are in an interglacial, and an interglacial that has lasted longer than most interglacials have. It is possible, I don't think it's at all likely, but it's possible that the only reason the interglacial has not ended is that we are generously warming the Earth. Indeed, I should say there is some pretty good evidence for what's referred to as the early anthropogenic hypothesis, which is that the reason that the next glaciation hasn't started is indeed human production of CO2, but from about 8 million years ago. That is, that the invention of agriculture resulted in clearing a lot of forests. That put a lot of CO2 in the air. And this is a serious argument. I've actually got one of my Substack posts is about it, about how the glaciers were held off by humans, Stone Age humans. So that's certainly possible. So I guess my general view, one of my books is called Future Imperfect, and it deals with technological revolutions that might happen in the next few decades. And my conclusion writing that is the future is very uncertain. There are all sorts of things that might happen, including obscure effects of climate change.
But those who did have to they won't. But those who have that uphold
Yep.
Could that affect the Gulf Stream if that was
It's getting warmer, not colder. But sorry.
I can't hear you out there.
Anyway, I think that's one question. Yeah,
Okay, Gary, I see you got your hand up.
One quick comment and one question. The comment is, I don't really think it's relevant to say mammals did well 13 degrees centigrade higher 100 million years ago, because we didn't have this complex interconnected world with huge coastal cities and the complex agricultural system we have right now. And 2 degrees or 3 degrees centigrade, well, I don't believe it will destroy it. I've been listening to other people who say essentially what you do on YouTube, like I think one is Lomborg.
Yes,
Although
I mentioned Bjorn Lomborg already in response to another question.
Okay. He will say what you do, and he makes a lot of good points. But my question is, what do you think based on your conclusions, what do you think of the efforts we're putting into alternative energies, be it solar, wind, geothermal, nuclear, and all of the money going into battery technology to support the wind and solar?
Right. You will notice that mostly the same people who argue for doing things about climate change also argue for shutting down nuclear reactors, which says something about the degree to which we're dealing with a religion rather than a science. But more generally, I think the development of other things is desirable. On the other hand, I'm generally skeptical about governments deciding what you should do and what you should subsidize. I think that's likely to result in not very sensible progress. But I guess that would be my response, that I think it is desirable if people find out ways of producing energy less expensively. On the other hand, since I am not convinced that CO2 is a bad thing, I don't regard it as obviously something that you ought to be pushing to do. And I would point out that policies of this sort can have very negative effects. In particular, you do realize that the US has a mass program of encouraging world hunger. It's called the Biofuels Program. The US is the world's largest producer of maize. We are currently destroying about 12 or 13% of the world's supply of maize in order to turn it into alcohol.
Yeah.
Maize is the chief food for about 200 million people. And those are mostly poor people, largely in Africa. The effect of what we're doing is to push up its price. By how much is hard to be sure. It's gone up a lot, but I don't know how much of that is due to biofuels. So that means that in the process of trying to control climate change, we are in fact starving people.
And I agree with you. Biofuels was never a great idea. you need to feed people first. One thing I just want to quickly say about this group from a meeting we had 2 weeks ago, I like, is we were talking about climate change and new technologies, and this group is almost all pro-nuclear, which I really did like.
Yes. Well, I am pro-nuclear in the sense I think you shouldn't shut down reactors. I don't know enough to know whether nuclear is in general a less expensive way of producing power. What nuclear is the one form of power that's a full substitute for fossil fuels other than transportation that can be expanded without limit, whereas you can't do that with hydroelectric, which is the other obvious one, and the other two are not a full substitute unless you have really good cheap batteries, which we don't have yet. Anyway, another question?
Yeah. What is your estimate, percentage-wise, I guess, on current anthropogenic effect on climate change? What percentage of the climate change that we're witnessing is due to human activity today? And
I understand.
Versus
Yeah, the real answer is that I don't know. I'm not an expert on that question. If you had to ask my guess, it's probably more than 50%. But climate is a really complicated system. And so you've certainly seen temperature changes that aren't due to anthropogenic. There's an interesting article which I critique on my blog. I'm not sure I've got it anywhere else, which is claiming to show that the probability that the climate change of the last century is natural is very, very low. And it turns out, if you look at it carefully, that it doesn't really show that, because it's got to make an extra assumption. What it's doing, it's interesting, it's an interesting attempt. What it's doing is looking at climate change over the recent centuries, basically, trying to fit that to see how much variation there is. And then saying, all right, this much variation wouldn't happen. But the trouble is that assumes that all of the causes of variation are things you can observe in a period of 300 or 400 years. If there are some causes which are much more intermittent than that, some cause that occurs on average every 1,000 years, he won't have it in his data source, and he has no way of knowing what its size or probability is. And this is what's referred to as a black swan event. Not only is that a possibility, it's real, because anthropogenic climate change is itself a black swan. That is to say, if you take exactly his argument, and we were going back a century plus before the warming started, he would just have proved that warming is not going to happen. Because, in fact, anthropogenic climate change is a large, rapid effect, which happens very rarely, so far once. Well, twice if you count the early one.
Matt, I see you got your hand back up.
Yeah.
Are you coming to me? Because Alex's mic is not working. So second follow-up question is kind of a follow-up to one of the other ones somebody else asked, but with the reduction in the costs of solar and wind, and now more recently, I don't know if you're following it, but the reduction in costs for batteries for EV cars, they've suddenly dropped quite significantly.
Yeah.
Have you updated these models that you've been, well, you've mentioned before, that talk about how much it's going to cost for the switch over in these distant future scenarios?
But my basic argument, as I thought I made clear in the talk, is not about what the cost is of preventing it. It's that we don't know if we want to prevent it. It's that the claim that we can be sure, even the claim that we can be sure that climate change has net negative effects, I do not think that one knows that's true. It might be true, it might not be. And the claim that it has very large net negative effects, I think there's very little evidence for it. That's why I'm citing Nordhaus as sort of somebody who has looked into this stuff in much more detail than I have. So no, if it really turns out that solar and wind become cheaper and batteries become a lot cheaper, then we don't need any special policies in order to do it. People will change. They prefer getting their power cheaply. I have solar panels on my house. Not, I should say, mainly for saving money, but because I don't trust the power company not to turn off my power, and I also have a big battery. I'm not sure, however, that the battery improvements on EVs are going to be relevant, because those are solid state batteries. And a lot of what matters there is energy density. But for your storage, if it's not in a car, you can have your battery as big as you like, right? So that the relevant question really is cost per amount of storage, not whether the batteries you're producing are well adapted to EVs.
I had a problem with the microphone here.
Yeah.
Apparently they can't hear me out there. Can I borrow your microphone to Ray? I'll get it back to you.
Sure.
You talked a lot about pros and cons of climate change,
Yes.
things that are beneficial, things that are negatives.
Right.
I'm wondering, have you done any estimates on the cost of species extinction?
No.
And
Yeah.
the other thing is, have you done anything to look at the costs of fossil fuel and biofuel pollution that I've heard is killing 8 million people prematurely per year?
The answer first is I have no estimate of the costs of species extinction. At the beginning, I mentioned that there was a sunk cost argument that suggests change is generally bad, and that I thought was a very weak effect for human beings. It might be a significant effect for other species, and it's very hard to know. Most species can shift their range. We're talking about, again, very slow change. But if you think about trees, for example, they can shift their range, but very, very slowly by, dying out at one edge and growing in the other. And trees evolve very slowly because they have long generations. And therefore, it might turn out that some species of trees die out in some areas, which would be unfortunate. And you can think of other effects of that sort. If you look at the IPCC reports, however, they are not actually claiming that climate change is causing species extinctions. They claim that the species extinctions are mainly claimed by human land use changes, mainly caused by human land use changes. Sorry, there was a second part of that I've now lost. What was the?
So the second part of that, I'm not sure exactly what I said, but you haven't covered species extinctions in the oceans. And
Nope.
The second part is, what about the pollution from burning hydrocarbon fuels?
Yes.
Both fossil fuels and biofuels.
Yes. No, I would have said that I'm not sure if biofuels have much pollution, because I'm pretty sure that the alcohol from maize is just alcohol. I don't think it's got the relevant things. No, I think the fact that some fossil fuels cause air pollution is a real problem, but that has nothing to do with climate change. That insofar as you can correctly estimate the costs of the sulfur or whatever, it makes sense to have something like a Pigouvian tax, some sort of a charge for putting sulfur in the air. Now, I don't trust the government to get it right, because my impression is that government policies often do more harm than good. But certainly in principle, in terms of the economics of it, that's an argument, but it's not an argument about climate change, which is what the subject of my talk today is.
Okay, Jim, I see you've got your hand up.
I respect your great deal of research into this problem, but one thing that concerns me is that you did not address the problem of human migration that is going to cause the greatest degree of chaos in relation to climate change, as I perceive it, as many areas of the planet become absolutely uninhabitable by humans.
Since that's not going to happen, I have not addressed it. What areas become uninhabitable? Look, have you ever tried superimposing a map of temperature on a map of population density?
What about the temperatures of 120 degrees or so in Pakistan and in India and some of these areas, and the enormous number of migrants piling up at our borders the number of migrants that are trying to leave Africa, it just seems like these migrations are going to be greatly enhanced by the severe changes in
I don't
climate.
think so. I think climate change is fairly small. The reason that there are huge numbers of people that want to come into the US is because the US is a much better place to live than South America or Central America. You do realize that the US in the period before and after World War I was getting 1 million migrants a year into a population of 100 million. That's 1% of the population every year was coming. And that had nothing to do with climate change. That was for the reason that my grandparents came, because this was a better place to be than what's now Ukraine, or was then, I don't know, Poland or Hungary or Austro-Hungary or something of the sort. So I think you're believing things that make good news stories, but I don't think that climate change has much to do with the movement, and I don't think there are going to be large areas. If you look at that population density map, the Sahara is empty. Sahara is not all that hot. It's warmer than here, but it's not one of the hotter parts of Africa. What it is a dry part of Africa. So there are lots of things that constrain human land use, but all I'm saying is the temperature by itself does not, at least if you just look at the graphs of temperature, at the maps of temperature, which you can find online, and at the maps of population density, you don't see a relation at the high end, only at the low end.
I have read that there's a large number of migrants from Honduras where drought has made farming impossible. Will that not occur in many other areas?
I don't know of any particular reason to expect drought to increase with climate change. I don't know whether you're saying is a correct description or not. I don't know enough about Honduras. I know almost nothing about Honduras, in fact. But in a changing world, some places get better and some places get worse. That the increase in CO2 means that plants need less water. That will tend to decrease the effects of droughts. At the same time, there is a change in weather patterns, which in some places may increase droughts. I should say, if you actually look at the IPCC, the map I mentioned on the summary for policymakers, they show a lot of areas with increasing droughts. I think only 2 of them, one of which is where we're sitting, do they say that there's reason to believe that it's caused by climate change. The others, they don't specify, they don't know what the reason is.
Okay, Jerry.
Have you heard of Jerry Taylor?
Have I what?
Heard of Jerry Taylor?
I don't think so.
Okay, he used to work for the Cato Institute, and he was a very good debater about climate change. You know, he debated. He's one of the best at debating it. And at one point, one of the persons he debated said, "You know, have you done all the research on it?" And he said, "Oh, so, you know, go check it out." So he went to somebody who knew about the science, and eventually decided, well, the science really wasn't there. So then he said the economics was still an important factor, until he met somebody who was like a guru on Wall Street on risk management, and said, from a risk management point of view, what we're doing is wrong. We need to take this much more seriously.
I'm afraid I know nothing about him, and given that what you have just given me is what third-hand information, your account of what somebody told you that somebody told him, it does not give me enough information to know whether I should change my opinions.
Okay, I just suggest you go check out Jerry.
All right. I think we're ready to break. Thank you for speaking, David.
So how do you provide virtual lunch for all the people who are on Zoom?
They usually credit you.
Right.
Oh, also, if any of you haven't done so already and you don't have your information, those of you on Zoom, if you just send that information, just your name and email to Matt on the chat line. We'd appreciate it.
And since they are recording this, you can find the various links that I gave briefly on the recording if you want to check out any of the sources that I've got.
Thank you.